Hi everyone, and welcome back to another session of Test Automation Engineer Certification. So we will continue with TAA design, and the topic we will cover in today's session would be approaches for automating test cases. So in order to design a good test automation architecture and eventually a successful test automation solution, we need to carefully adapt to what kind of test automation approach we will be using, and that's what we will be covering in today's session. Test cases need to be translated into sequences of actions which are executed against an SUT. That sequence of actions can be documented in a test procedure or can be implemented in a test script. Okay, so over here, either it can be documented in a form of a test procedure with all the steps of like all the preconditions and whatever is required for the test case, implementing test cases, or it can be directly implemented in a test script. Now, besides these actions, the sequence of actions, the automated test cases should also define test data for the interaction with the SUT and include verification steps to verify that the expected result was achieved by the SUT. Okay, so which means that apart from the sequence of actions, also, what needs to be there is a stable and robust test data and should also include the steps of how to verify the results. A number of approaches can be used to create the sequence of actions, and let's see that what are those. Okay, so let's see what options we have. The first one is the test automation engineer implements test cases directly into automated test scripts. Okay, means that implement these manually into the test scripts. The features of this option, it's the least recommended option because it lacks abstraction and increase the maintenance load. The approach which is used for this option is the capture playback approach. Okay, so in the syllabus it's mentioned that it's capture playback approach, but later on when we will learn for the linear scripting, that will also be applicable to this option. But for now, because we have to follow the syllabus, then we should just go with what's mentioned over there. Okay, number 2, the test automation engineer designs test procedures and transforms them into automated test scripts. Okay, now in this option, we have abstraction, but still it lacks automation to generate the test scripts because still it's being done manually. Okay, so what kind of approaches will be suitable? Structured scripting approach, data-driven, and keyword-driven. And we will be discussing all these approaches in detail. So let's just go through these options for now. Okay, number 3, the test automation engineer uses a tool to translate test procedures into automated test scripts. Okay, now in this option, it combines both abstraction and automated script generation. And again, the approaches which are linked to this kind of option is structured scripting, data-driven, keyword-driven. And the fourth one is the test automation engineer uses a tool that generates automated test procedures and or translates the test scripts directly from models. Now, this option has the highest degree of automation. And the approach used is model-based testing, including the process-driven approach. Okay, the note over here is the options are heavily dependent on the context of the project. It may also be efficient to start automation by applying one of the less advanced options, as these are typically easier to implement. This can provide added value at short term, although it will result in a less maintainable solution. Okay, so now we have 4 options over here, and we will be discussing different approaches which we can use to implement our test automation architecture. So we can use to design a successful TAA. Okay, so now if we look at option number 4, it says that it has the highest degree of automation. So if we say that yes, if this is the ideal degree of automation, then why don't everyone just use this option? Why some people they go for the other three options? And this is because we have to see different factors as mentioned. First of all, the context of the project. Maybe the project is a very small project which might doesn't need the complexity of option 4, or maybe the first option is good for someone who is beginning automation testing, because they have been doing manual testing and now they want to step into test automation. So option 1 is good for beginners and for many like small projects as well, even though later on it will be difficult to maintain. But it all depends on the scenario of like of the organization and the project you need to automate. So that's why sometimes we can go with the less advanced option as well, because that might work well in short term for us and maybe it serves the purpose. Okay, so now let's go through how many approaches are mentioned here. So we have 7 approaches mentioned in the syllabus: capture playback approach, linear scripting, structured scripting, data-driven testing, keyword-driven testing, process-driven scripting, and model-based testing. And today we will cover the first two, capture playback approach and linear scripting. Okay, so capture playback approach, what's the principal concept? Tools are used to capture interactions with the system under test while performing the sequence of actions as defined by a test procedure. Inputs are captured. Outputs may also be recorded for later checks. During the replay of events, there are various manual and automated output checking possibilities. Okay, so now this approach, capture playback approach, it's the simplest approach to automate test cases. And it's recommended for beginners, for any company who are beginning is in their transition phase from manual to automation. They can start with this approach. And in this approach, there are many tools like open source tools and also extensions as well, which can be used to just record playback, where you will record all the actions against the application you will be testing, and you can then play back the recording and execute the results. There are different ways in which the results can be compared against the behavior of the system or application, whatever you are testing. And that's what I mentioned over here. So let's see what are those. First of all is manual. The tester has to watch the system under test outputs for anomalies. Means like it's a manual way of checking. Complete. All system outputs that were recorded during capture must be reproduced by the system under test. Means over here, whatever when you recorded the scripts, whatever the output is, now output can be the data, it can be text, it can be the way the screen is displayed, etc. as well. It should be the same as reproduced by the system you are testing. So comparing that, it should be the same. So this is the complete one. Now the third one, exact. It's quite similar to complete, so that's why it's important to understand the difference here. All system outputs that were recorded during capture must be reproduced by the SUT. See, now till here it's the same as the previous one, complete. But now what is there in addition? To the level of detail of the recording. So now over here in exact, we are doing everything which is incomplete, but we are doing in quite level of detail. We are going into details and checking that everything is exactly identical. And the fourth one is checkpoints. only selected system outputs are checked at certain points for specified values. Means like during test execution, only specific outputs are checked at different places. Okay, now let's go through the pros and cons of this approach. So we already know that this is the most easiest and simplest way to automate test cases. It can be used for system under test on the GUI and or API level. So we can use it for both GUI level and API level. Initially, it is easy to set up and use. And why it is easy to set up and use? Because there is no planning required. You just need the tool, understand the tool and start using it. And no programming skills are also required, and the development cost would be quite low. So it's a good way to just start automating and then evolving maybe to another tool, or maybe if you have a very small scope of the application testing, then also it can be used. Now let's see what are the cons. Hard to maintain and evolve, because the captured system under test execution depends strongly on the system under test version from which the capture has been taken. For example, when recording at the GUI level, changes in the GUI layout may impact the test script, even if it is only a change in the positioning of a GUI element. Therefore, capture replay approaches remain vulnerable to changes. So yes, so this approach is very hard to maintain and very hard to evolve, because let's say, as mentioned, that even if you are changing the position of a GUI element, any text box on the form, you are just changing its position slightly. This means that your earlier capture playback will not pass. It will fail. And sometimes it also happens that even if you haven't made any changes, the tool actually needs everything to be the same. Even like sometimes there can be an infrastructure issue as well, maybe the any resolution issue, or maybe the page loaded a little bit differently than it did when you recorded the script. So sometimes even when we are not even making a change, even then also it fails. So these tests are very, very fragile. Implementation of the test cases scripts can only start when the system under test is available, which means that like we can't automate the scripts until the system under test is available, which means that it is like we are already towards the end of the life cycle. Okay, now let's see the next one, linear scripting. Okay, so as I said earlier, that linear scripting is quite similar to record playback, and sometimes when we talk about any record playback tool, it refers to linear scripting as well. So linear scripting, we can say that it can be seen as an evolved capture playback approach, and let's see that how it is different. As with all scripting techniques, linear scripting starts with some manual test procedures. Note, though, that these may not be written documents. The knowledge about what tests to run and how to run them may be known by one or more test analysts. Okay, so over here also we are starting with the manual test procedures, and it's saying that these test procedures doesn't mean that they always will be very well written documents. Sometimes it can be that it's just depending on the knowledge of a specific test analyst. Okay, now what we do in this scripting. Each test is run manually while the test tool records the sequence of actions and in some cases captures the visible output from the SUT to the screen. This generally results in one typically large script for each test procedure. Okay, so now till here, doesn't it seem the same as the record playback? Because in that also we are doing the same thing, that we are capturing all the actions and then we get an output. Okay, so now what's the difference? The recorded scripts may be edited to improve readability, for example, by adding comments to explain what is happening at key points, or add further checks using the scripting language of the tool. Okay, so now this is the part where it differs from the record playback. So in record playback, when we are just so what we are doing, that we are recording, we are capturing the sequence of actions against a system, and then when we are playing back that recording, then we have a script is generated, but we can't edit anything in it. But in linear scripting, what we can do, we can add, let's say we can add comments in the script, in the code, so that it's easily readable, maybe someone else who later on wants to execute these test scripts. And we can also add different checkpoints as well, the different verifications, if we go ahead and understand the scripting language. So that's where it is different to the capture playback. The scripts can then be replayed by the tool, causing the tool to repeat the same actions taken by the tester when the script was recorded. Although this can be used to automate GUI tests, it is not a good technique to use where large numbers of tests are to be automated and they are required for many releases of the software. This is because of the high maintenance cost that is typically caused by changes to the SUT. Each change in the SUT may necessitate many changes to the recorded scripts. Okay, so so just like the capture playback, linear scripting is also recommended for a very small application. So not for something which is quite a large application. And why is that? Because each test case has to be recorded separately, or if we are manually implementing, then it has to be implemented separately, which means that each test procedure will have a separate automated test script, and which means that eventually the line of code will increase massively and it will be difficult to maintain. Now let's go through the pros and cons of this approach. There is little or no preparation work required before you can start automating. Once you have learned to use the tool, it is simply a matter of recording a manual test and replaying it. Although the recording part of this may require additional interaction with the test tool to request that comparisons of actual with expected output occurs to verify the software is working correctly. Okay, so over here as well, I would say that no to little planning is required. Programming skills are not required, but they would be helpful, because if you have to make any edits, then it will be good that you understand the tool and also the programming language used by it and whatever the format is, so that if you want to add any comments, you want to add any verification checkpoints, then you can make those changes in the script. Programming skills are not required but are usually helpful. So yeah, as I already mentioned, that they are not required, but it would be good, because then you can understand and use the tool easily, and you can also make the required edits, whatever are required in the script. Now let's go through the cons, and there are quite a lot cons for this approach. The amount of effort required to automate any given test procedure will be mostly dependent on the size, number of steps or actions required to perform it. Thus, the 1000th test procedure to be automated will take a similarly proportional amount of effort as the 100th test procedure. In other words, there is not much scope for decreasing the cost of building new automated tests. Okay, so what does that mean? That every time a test case is being automated using the linear scripting approach, a new test script is generated. This means that the more test cases are automated, the more lines of codes are generated. And it doesn't mean that that as we will keep on automating then we can't like reuse any of in this one there is no option of reusability. So that's why it doesn't mean that the 1000th test case would be would take less time than the 100th one. Actually, it will take the same time. This means that as the number of automated test scripts will increase, the time and cost for maintaining those tests will also increase. And it also means that whenever there is any change in the functionality, then all the affected test scripts you have to make those changes over there, which will take a lot of time. Okay, next one is if there were a second script that performed a similar test, albeit with different input values, that script would contain the same sequence of instructions as the first script, only the information included with the instructions known as the instruction arguments or parameters would differ. If there were several tests and hence scripts, these would all contain the same sequence of instructions, all of which would need to be maintained whenever the software changes in a way that affects the scripts. So over here also we can't this is non-modular, so that's why we can't change them into like different modules, which means that even if like there's a slight change in the script, and or let's say there's the same script but it's using different input values, and because it's hard coded, so that test data for each different combination you need to use separate test scripts, which means like there'll be a lot of automated test cases. Okay, so the next one is, because the scripts are in a programming language rather than a natural language, non-programmers may find them difficult to understand. Some test tools use proprietary languages unique to the tool, so it takes time to learn the language and become proficient with it. Okay, so now over here there's a dependency on the tool we are using, because let's say if we are using C# or Java, then of course we can use it using different editors, and the language would be the same. But over here, as we are using different specific tools for the linear approach, we need to go through the learning curve of understanding that language, and sometimes it might be what you're not familiar with, and maybe the next tool you'll be using will be totally different, and the format of the scripts is also totally different. So in order to make any changes or to understand the script in a better way, you need to go through the learning curve. Recorded scripts contain only journal statements in the comments, if any at all. Long scripts in particular are best annotated with comments to explain what is going on at each step of the test. This makes maintenance easier. Scripts can soon become very large, containing many instructions when the test comprises many steps. Okay, so as with this approach, with each new execution, it will generate a new test script. And though we said that in linear scripting we can edit and we can add comments and add which can be useful, but as the number of test cases and the steps are increasing, then it will be difficult to keep on doing that for those many test scripts. The scripts are non-modular and difficult to maintain. Linear scripting does not follow common software reusability and modularity paradigms and is tightly coupled with the tool being used. Okay, so it says that it's non-modular and non-reusable. So if there are any changes to the system under test, that needs to be manually applied to all affected test cases. So what is the modular approach. So modular approach is basically that the test cases can be broken into small parts. It can be maybe categorized by functionality or something else, which are called modules. And then these small parts can be reused to create new test cases or test scenarios. Now, linear scripting approach doesn't allow modules that can make test scripts reusable. And also the test scripts, they are also tied up with the tool you are using for linear scripting, which is being used for recording. Now, each tool will have their own format. It depends on the format of each tool, whether programming skills are required or not to understand the scripts. Okay, so as we have gone through these two examples, which are quite similar, but I hope that you are able to identify the difference if a question comes in the paper. So you should be able to identify that which one is capture playback and which one is linear scripting. Okay, so let's go through a very simple example to basically understand what we have learned so far. Okay, let's say that there is an application, and the scenario which we need to automate is this, that we have to log into the application. It's a very simple application. So you have to log into the application, and then in the application there are different menus. So you have to check all the navigation through the menus, that everything is working, and then you log out from the application. Okay, so now for this kind of automation, for this kind of scenario, linear scripting would be good. So because all you have to do is that that there is a specific login. You can use that login to login details to log into the application multiple times, do the navigation checks and log out. So over here there is no issue, and if that's all you need to do, let's say 100 times in a day, then automating using linear scripting is a good idea. You can do that. Okay, now let's see another change in the same scenario. So far everything was good, but now you have to add another step to this scenario, which is the registration to the application. Means that now there is a new user. You have to automate this scenario where the user register to the application and then log in, check the menu navigation, log out. So means like until we had the application of that scale where all we had to do was checking login, logging, navigation, log out, automating that much was fine using linear scripting. Now what would be the problem in the second one? Now when we are registering to any application, there are some unique fields which can't, for example, there is an email address. Let's say it's a unique email address. If you enter the same email again and again, it will identify that, oh, you already have an account with us, so please log in using those details. So now the first time when we will automate it, we will run the test, it will work perfectly fine. It will create an account. Second time, if we will try to run the same test, it will fail because that email address has already been used, which means that if we have to do 10 registrations in a day, then every time manually we have to go and edit that part of the script where the email address is given, because that part, that's like a test data which is hard coded in the test script. So we have to every time go and change the email address, which is unique, and then run the test, which means that now as we are adding more scenarios to the application, it's getting harder to maintain it and it's harder to scale it. And this is like a very simple one scenario added. Later on, maybe this the application will evolve and there will be many other complex test scenarios which might not be feasible using linear scripting, or it will not be easier to maintain using linear scripting. So that's why it's very important that when we are trying to design our test automation architecture, we are also deciding that what kind of test automation approach we will be using, which one is suitable to our situation, to our project, and which is in long term we can maintain, we can extend as well. So I hope that today's session, it was helpful and you do understand these two approaches, and in the next session then we will continue the other ones. Till then, thank you so much. Bye.